As two chefs were hiking in the Highlands of Scotland near Calvine, they suddenly saw an object and hid behind some bushes, then, to take a photo of the object. Here is the photo, and with the premise above, let us try and dissect the surrounding scenery. Viewpoint A. The view that contains the standard orientation. Now let us start out by using the Blender 3D software tool. In the process of trying to get wiser on the matter. From this angle of the photo we get different kinds of information, and if we are to build upon the most relevant, we will now set our focus upon the close distance plant fauna. The viewer is subject to a small branch in the bottom left corner, that seems to be the outermost needles on a small bushy pine tree. Secondly, in the top we observe some small leaved branches hanging down, which most likely are from a birch tree. But so far something very important is missing in the scene, and that is the ground of which the photographer is placed upon, when taking the shot. While the ground is placed in the negative space outside the frame of the shot, the visible fence is also located quite close to the photographer. In the bottom there are also some mountains to the left and shadows to the right that seem to display a contour of round tree tops. This last mentioned content will not be handled in this video. The airplane with different left/right wing lighting, that seems to be behind the diamond-shaped object, will only be elaborated upon minutely. List of explanations by most likely common objects. We now move into the debunker's arguments for what the object can be. And here is a listing of the most likely real-life objects that is put forth as explanations. An above-water bedrock tip, within a shallow pond reflection. A square-shaped kite. 2. A balloon. Viewpoint B, the above-water bedrock tip explanation. The view that contains the reversed and upside-down orientation. This explanation suggests that the photo contains a pond that reflects various content. As the hillside ground within the Scottish Highland areas consist of a stony bedrock, the bottom of a small water body would be rocky. This becomes relevant if we dive into the above-water bedrock tip explanation. At this point we will have to change our point of view and make the photographer's camera angle steeper, and while doing so the frame can now contain a pond reflection that implies a reversed and upside-down orientation of the shot. Due to rules for perspective and distances, this changes the assessed position of the little pine tree that now has to be located closer to the pond than the birch tree. As most debatters, who lean towards a logical phenom argument, tend to back this explanation, we will dissect this in the most detailed manner. The above-water bedrock tip explanation. Detail A, the front edge of the bedrock tip. While trying to mimic the reflection of the tip, one would want to start out with a tip volume that resembles an elongated pyramid when seen from a top view. The above-water bedrock tip explanation. Detail B, the horizontal line conundrum. Within the 3D software it is possible to set the light source in such a way that the required shadow appears in front and below the tip. But if we go back to the photo's all-important horizontal line, we quite quickly discover that the given volume's shape will force certain demands of the shot angle. If we elaborate upon this view from a separate setup, the principles of perspective require the shot to be taken at a very low angle. which again opposes the recent premise of the steep angle shot, that also included the trees and the fence. Although this weakens the above water bedrock tip explanation, there is still an opportunity for the tip to be shaped in a very special way. So let us try to do so, and alter the stone tip's volume. Please notice that there is very little difference in the color of the tip, and in the color of its reflection, within the 3D rendered world. With this particular clip section we alter the pond's reflective properties in order to point out and disseminate this very crucial part of the whole scene. Now when we have come close to having a tip that mimics the explained tip on the reversed photo, we should still try and compare the adjusted tip volume to how loose stones present themselves in ponds and rocky waters. In this small sample size of 12 images it becomes clear that horizontal lines seem quite rare amongst water lines between above-laying stones and the water bodies they lay within. The above water bedrock tip explanation. Detail C, colors within the mirrored front area. Let us now continue to elaborate upon the colors of the real-life stone examples. For best practice regarding RGB color and light comparisons we divide them into two categories. The first category looks upon cases of semi-transparent water bodies, and the other one will contain examples with opaque water bodies, with full reflection. This division of the stones is a sorting method we will use, as an extra precaution. Although with minor effect, it should mitigate that the water reflections can contain different color complexities due to the object's surroundings. Two stones from the angle comparison clusters will not be taken into reflection color consideration, as their dark pond bottom surfaces seem to darken the reflection more than the actual Calvine photo, which tends to reflect a brighter reflected sky itself. We will now revisit the example clusters of stone image reflections, for then to compare it with the two proposed tip and reflection areas in the photo. The results are a color difference average of 20.5% for the semi-transparent examples, and a color difference average of 9.7% for the opaque examples. So if we now calculate the difference for the diamond shape object, and revisit this slide, we find that the color values between the proposed bedrock tip and its reflection result in a difference of 28%. Due to the very rasterized nature of the original photo, different samples were taken. The sample with the lowest found difference value still resulted in a difference of 18%. Although the airplane in the image is controversial, we can still, and finally, use this flying object to do a minor comparison regarding light direction. If the diamond shape is really hovering and, as such, is not a bedrock tip that connects to the rocky bottom, the brighter wing contains the same light properties as the diamond-shaped object. The shading seems similar, as both the upper airplane wing and the top diamond shape appears brighter. Last mentions. The next two explanatory subjects will be touched upon in a brief yet efficient manner. If the square-shaped kite explanation should make sense, the bought or self-made design would have this dark and light side appearance. Furthermore, the very extreme and yet string-constrained angle makes the kite scenario very unlikely. Here is a small collection of boys holding and or running with a kite. If one were to compare the stock footage of a square-shaped hobby kite moving around, one would discover that a 90-degree string-constrained angle almost never occurs. The kite will, extremely seldomly, be in a position where the backbone stick is positioned in an angle parallel to the ground, unless the controller of the kite is dragging the kite with great force, and with an angle that is very perpendicular to the ground, of which the controller is placed upon. The design of the kite seems odd in comparison to other kite designs in the 1990s. One should assume that the proposed kite, in the Calvine environment, was photographed in light conditions with a sun angle from above. This implies that the kite would be hit by the light source from above, which force the design to have a dark and bright appearance and look like this. The explanation of a balloon. In order to fulfill the argument of the balloon explanation, two premises will have to apply. The balloon should, first of all, be filled with a lighter than air substance that makes the balloon hover. Secondly, the girders or framework within would have to be strong enough to give the balloon a sharp-edged and diamond-like appearance, despite being filled with a gas. Now, let us try and simulate what happens to a diamond-shaped balloon when it gets filled with gas. Normally the surface material of balloons are made of thin and lightweight substances. In this image the hovering and diamond-shaped object is estimated to possess dimensions between 2 and 25 meters in length. By common sense and first-hand knowledge, balloons of this sized aerial vehicles do seldomly contain a strong inner structure. Older Zeppelin balloon types contained a wooden structure just below their outer surface, but this is not the case for modern blimps. Modern blimps contain so-called ballonets which are inflatable themselves without girders. Normally the following premise, to such a structure, would imply that strength will cause the foreseeable weight trade-off. As sticks are lighter than steel, the latter will, in practice, never be used in a lightweight balloon. And the most likely compromise would be to use a carbon fiber structure. As such carbon fiber sticks do have more elasticity than steel, here is the final visual estimation of the most likely appearance of the object, should the diamond-shaped object have been a balloon.